Hi everyone, welcome to another webinar by Royal Cyber. My name is David Alaman and I'll be your host today. This webinar will be a little bit different from many of the other webinars you may have seen, just because of the subject matter at hand, natural language processing. The main purpose of NLP is interpretation and personalization. By analyzing and understanding the context of user inputs, the machine is able to generate appropriate actions, responses, or evaluations of text. With this in mind, we've prepared this webinar to reflect the power of natural language processing's ability to create human experiences. So as opposed to the usual sleep-inducing webinar, this webinar will be more of a back and forth discussion with Mahipal, my co-host, and myself. So send in your questions as they come, and I will have them answered as we go. Our agenda today is as follows. We'll briefly go over a general, high-level introduction to NLP. Then we will speak on how Royal Cyber fits into your NLP journey. And finally, we will go a little deeper into the technical side of some NLP use cases for text analysis, chatbot, and e-commerce search, followed by a brief demo. All right, so first off, we'll start with why NLP. Study of Brilliance suggests that up to 31% of e-commerce site revenue is generated from personalized product recommendations. McKinsey reports 35% of Amazon's revenue is generated by its recommendation engine. Everyone uses Netflix here probably close to daily, and I'm sure that 70% of everything being personalized is no shock to anyone. And of course, ROI on market spend can improve sales by up to 10% or more. So what is natural language processing exactly? NLP is a branch of artificial intelligence that helps computers understand, interpret, and manipulate human language. Natural language processing draws from many disciplines, including computer science and computational linguistics, in its pursuit to fill the gap between human communication and computer understanding. The goal here is to structure a highly unstructured data source. And so why is NLP so difficult? Well, the human language is astoundingly complex and diverse. We express ourselves in an infinite number of ways, both verbally and in writing. Not only are there hundreds of languages, dialects, but within each language is a unique set of grammatical rules, terms, and slang. When we write, we often misspell, abbreviate, or omit punctuation. When we speak, we have regional accents, we mumble, stutter, and borrow terms from other languages. A very difficult example is something like sarcasm. It's easy for a human to understand the nuances of speech, but it's not as easy for a machine. And here's actually an example of natural language processing gone wrong. Back in its nascent stage in the 1950s, some words were translated between Russian and English, so the biblical sentence required translation. The spirit is willing, but the flesh is weak. When translated to Russian and then back to English, the response was, the vodka is good, but the meat is rotten. Close, but no cigar. As a quick aside, I would be interested to hear if any of you begin to question the way you speak and write and notice how many colloquialisms you use after this webinar. I know as I was writing this that I noticed a lot of times I'd use words such as, meat and potatoes and things like that. And you'd be shocked at how confusing that can be for a machine. And some of our accomplishments with NLP, so that 5% increase in conversion rates, that's actually something we just implemented on a high-burst platform. It's not 100% yet as far as the final stats go, but that's roughly what we're looking at. With Chatbot, we've had 52% saving in operative expense cost savings. And that was done through translating in different languages so that the customer could have customer support 24/7. And our biggest one, and this is kind of an outlier, is 17% increase in conversion rates with a sportswear company. 17's pretty high. Luckily, we were able to do it and we were able to see that, but that might be close to the ceiling. And so now, Mahipal and I are going to do a little bit of a back and forth here. He's going to explain how NLP works, and then we'll be having some questions throughout, and we'll go from there. So Mahipal, could you please let us know what's going on here?
Sure, David. Thank you very much, and welcome you all for this webinar. So this is, as David explained in the high level, what is NLP? It's about understanding the human language and translating into the machine so that machine can understand and make certain decision about it. And that's where the real game is. If we are able to convert in an order where machine can understand, then only it makes sense. So these are the various components of the process involved into the NLP. The first thing start with the various sentences being given for NLP processing. The first and foremost steps is the lexical analysis. So when it's a lexical analysis, it's about identifying each word from the sentence and assign a particular post tag. So when I say post tag, it is about identifying whether word is a noun, whether word is a verb, whether word is a determiner, or whether word is other type of English construct. So this can be English or any other language. With language, it adds to the added complexity of parsing them. So that is what the first step is about, lexical analysis. Once you're done with the lexical analysis, then comes the syntactic analysis. This is about creating a group of words from the identified word and create a various phrase, like which words are coming together. So it's a noun phrase is there, verb phrase is there, proposition phrase is there, which we're gonna talk about shortly. Once you are able to do this, is more of a mechanical and engineering activity. Now next comes the semantic analysis. This is about identify the sentiments and opinions from the sentence has been given, and this is very highly context driven. There is a general English language sentiments and opinion, but apart from that, it can be highly context driven based on your use case. Different set of sentiments can be identified specific to particular use case as well. And once it's all done, either this data will be indexed or stored with much more intelligent form, and then later will be used by queries, and an output will be generated by looking at database or any other index or any other source.
Awesome. And so basic NLP includes tokenization, parsing, lemmatization, parts of speech tagging, language detection, identification of semantic relationships. And of course, in general terms, NLP tasks break down language into shorter elemental pieces to try and understand the relationships between these pieces and explore how the pieces work together and create meaning. So, Paul, how would all of this be done?
Right. So this is the various high-level NLP capabilities we're going to talk about here. The first thing is the content categorization, because we have in any kind of systems, we have various type of content. So that contents we need to divide into multiple categories. For example, if we take a reference of e-commerce, at the high level, there is a two type of content normally every e-commerce site has, or any specific e-commerce site will have. One is the product data, where the actual product name, description, and their product attributes. That's the one set of content. The second set of content is the various menus, reference guide, those kind of content. So we need to, from the input source of data, we need to do that high-level character content categorization to divide the content into particular groups, so that each group needs to be processed separately by applying different rules to them. Second step is about topic discrete modeling, and this is one of the most complex part of NLP, where when the millions of data of the content coming into picture, we need to parse against the out-of-box models like English language models and other out-of-box models which are readily available by various NLP libraries. Also, at this point of time, in a very intelligent system, we build up the model also. Like when I'm passing the millions of data for a particular company of e-commerce, we will be building a specific models according to that context. Like models could be like a price model, where models could be a particular product characteristics model like color, size, variant, type. So those kind of data we receive from the data set and generate the models as well. After that, once the models are built up, we do the contextual extraction from the sentences to assign a specific data points and rank them so that those contents will be tagged properly. Data can be used by specific queries. Once all of these are done, then comes the sentiment analysis, as we discussed earlier. From this set of information, we try to give a different dimension and add sentiments to the particular sentence or a particular context, so that we can understand the overall situation and context in which that particular sentence or group of sentence has been mentioned. In the last, it's also in kind of chatbot kind of application. We need to convert into the speech to text, and as well as text to speech conversation also includes.
Okay, awesome. So this may seem like a slight detraction from search, but text analysis can inform your search capabilities in areas such as marketing and creating buyer groups. In fact, real estate, finance, and healthcare are all heavily using text analysis. For instance, NLP can be used to create a synopsis of a highly technical medical document for patients. So, Paul, how would this be done?
Right. So now we are little bit deep diving into the particular constructs of the NLP, syntax of the NLP, how the particular sentence been parsed and the meaning is generated out of that. The first thing, there are multiple high-level components involved from the syntax. There is a one thing is about constitute. The syntax rules generally involves atomic token made up of group of words, also known as chunks. So like example, the big house, the red and large carpet. The second thing comes is the grammatical relationship. The relationship between the subject and object. So like here in this example, I fly airplanes. So here the subject is I, you, and the object is fly aeroplane. So this way we identify the various grammatical relationship. Another example is he took the big hammer. So here the subject is he and the big hammer is the object. So this way we identify the grammatical relationship into the sentence. Once that is done, we build up the dependencies. The dependency are the rule that express constraint between words and phrase groups. So here the example is given that fly can be only followed by noun or noun phrase, where design can be followed by infinitive. So that example is I desire to fly. So similar way, I want to walk, I want to have a cake. So that way we identify the various dependency between words and create a various groups, which is noun phrase, verb phrase, or preposition phrases.
Okay, awesome. And so, of course, these are fairly simple sentences, but as sentences get more complicated, more tools are going to be needed, such as chunking.
Right, very true, David. The chunking is a process which tends to include tokens comprised of group of words. So there is a multiple components involved here. Is one is a noun phrase. So when first we identified various each word level, whether it's a noun, it's a affirmative, it's a verb. Out of that, we created noun phrase which are related to the nouns. Then we create the word phrases. So word phrases could be a much more complex as well. As we give an example here, it could be a simple one word carry, or it could be followed by a noun phrase like carry the box. It could be followed by a proposition phrase, carry around the house, and it could be followed by both of them, so carry the box around the house. So this way, as you follow the process, first we identify at the word level, then we create various groups and relationship, and next comes the checking where you merge the multiple group to make a particular context. So this context will be stored as a word phases, and later it will be used in that context.
Okay, that's pretty interesting, but it seems like prepositional phrases might get a little more complex because they can be followed by so many different variations and long strings of variations of different types of phrases.
Yes, yeah, proposition phases are, it's sometimes very difficult to identify as well, and we need a strong library to be identified there. And, this is on English library, and automatically we can add our contextual library to tweak this library to identify based on our context as well. So here proposition phrase is followed by verb phrase and noun phrase. That is like to the proposition which is followed by start the little red car. So start the little is the verb phrase and red car is the noun phrase.
Okay. And so now if we go into an entire example of a full sentence.
Yes. So this is like what we have discussed so far. It is a put it into the one picture together to make all of them sense together. So the example here is a dog is chasing a boy on the playground. So that is a sentence being given to identify for NLP processing. As a first step, we talked about lexical analysis. You can see that each word from the sentence being assigned to a particular post tag. That is, the word is a post tag, which are date, noun, auxiliary, verb, like that. Once the post tags are identified, the syntactic analysis starts, where we create various phrases out of these words. So there is a noun phrase, which is like a dog. Then there's a complex verb phrase, is chasing. Then another noun phrase come into picture, a boy. And then finally the noun preparation came is a on. And finally the playground is another noun phrase. So these are the first layer of phases are created. Then this next level of phases will happen where we identify the prep phase which is on the ground. Then we identify the verb phrase is like is chasing a boy. And there is a noun phrase is a dog. So this way, the complete sentence being created by the synthetic analysis.
Okay, that makes sense. But what's going on with the semantic analysis on the left side there?
Yeah, that's an interesting question. So semantic analysis is identify the thought process or sentiments or opinion or something which is very intelligent value, and it is the one which drives a entire mood of the situation. So for an example, from this example we can identify that there's a dog, there's a boy, there's a playground and chasing, and using this information and comparing against our various models created, we can identify scared if chasing. So there's the interference we receive is like a scale. The sentiments we assign to this particular sentence.
Okay, awesome. And so now let's move on to Chatbot. So outside of autocorrect and language translation, I'd probably say that Chatbot is one of the next most widespread uses for NLP. Almost everyone here remembers the early days of chatbots, which were daunting experiences to say the least. But with advances in natural language processing, 80% of customers who have engaged with the chatbot report an overall positive experience. And according to a Salesforce study, 69% of consumers prefer to use chatbot just for the speed at which they can communicate. So now if we go in a little bit more into how this is done, Paul, could you tell us about intent recognition?
Sure. So this is the first and very important state of the chatbot where you identify intent of a user who is interacting with the chatbot. Because based on the intent, you're going to present them the next set of products or next set of course of action to be done. So intent recognition match a user awareness, which is currently intended task or question. We do that through several different training models that define the combination of words that typically indicate the intent. So here the intent is want dress. So basically it's looking for a product search. So from the sentence they've written, we need to identify by matching against the various model we have, and we come to the identification that this particular person at this point of time looking for a searching a some product.
Okay. So now when we move to the entity extraction, how does this affect that?
Yeah, so entity extraction, as the name suggests, we need to identify entity that is in context of our business so that we are able to present them with specific products or guide the next set of conversation. So goal of entity extraction is to identify elements needed to complete the task. These elements can be simple items like numbers, dates, or complex items like address or any other domain-specific product categories. In this particular example, we identify three entities: the red, dress, and white, and then this entity will be mapped against our model to identify their meaning. So from that, red is a color, dress is a category, and white constitutes to gender.
Oh, interesting. So now we go into sessions when it comes to the chatbots. This just allows the chatbot to recall information given during the session so that the user is able to complete multiple tasks at once as opposed to repeating themselves. Easy example would be ordering from a wish list. So here, of course, what items do I have on my wish list? $50 green blouse and a $100 tennis racket. Order the green blouse and voila, and as little as 2 messages, a customer is able to place an order. And so now could you go over a little bit more on context, which obviously gets a little more complex here, Paul?
Right. So context is a very important information which allows a chatbot to remember in which particular context user interacted with the chatbot, and when there is an enterprise bots are involved. When there is a more than one chatbots user are interacting with, like when user logins to a particular company website and then they go to different department or different places where chatbots are there. So by remembering the context, we make end user experience much better by remembering lot of information they will be provided to particular bot and recognizing that information in another bot. So user feels like a personalized uh, information been remembered and presented to them, so they don't need to give that information again and again to each of the chat box there, or they don't need to give the same information again in the same session. So generally in the context, we remember information like name, business, address, and little bit of payment information what can be stored.
Okay, and so how would this affect website performance in general?
Right. So this way, users definitely gets more personalized response from the chatbot. So overall, it will help them to make the decision much better and faster, and that way, overall, it impacts into the sales or upsells.
Okay. All right, so let's go into an example here. So customer says, hello, hi Sally, how may I help you today? Like for some office supplies, would you like a repeat? Yes. And again, this is incredibly useful for B2B sites where repeat orders are pretty much the norm. It's very rare that you're changing something here and there, and if it is, I'm sure it's just a quantity, which Chatbot can't be trained to do. So now we're going to go into a search engine demo. All of these technologies can be leveraged to create an amazing customer experience. According to Gartner, smart personalization engines used to recognize customer intent can help businesses increase profits upward. And so, since all of you have made it this far, we are offering you a complimentary search workshop. We will be providing a search assessment, steps on cleaning your data, which should always be step number one when it comes to implementing NLP, right, Manipal? And then, of course, Manipal might actually be able to help you out with the best use cases for your industry, because sometimes it might be customer facing, sometimes it might be internal, such as that example with healthcare given previously. All right, let me get this demo going.
Correct. So while you go to the demo, I just like to explain few terms in terms of particularly in terms of end user facing or a B2B e-commerce website, like how the NLP steps been done. The first thing, and all of you associated with the e-commerce domain understand that catalog enrichment and normalization, where from the catalog we identify the particular product and then assign the data points to it. For an example, if there is a t-shirt, so then we identify what is the color of the t-shirt. Then is it a loose fit or tight fit? Is it for which genders? Is it for short sleeves, casual, cotton? In which particular season, like summer, it will wear. So this way you identify the from particular set of information and generate your own customized model. And that is what you've done with demo as well.
Oh, great, thank you so much, Manipal. So let's just do a basic example here. So if we look up jeans, we get right here, let me actually increase this a little bit, 269 results, just jeans in general. So now if we type in now again, this is fairly simple as far as making these changes. Drop down to 54 results. Now if we go into you'll then see the patterns change here. Now if we make it go just a little bit more complex, we can actually do price ranges. So from 30 to, let's say, 150. We will go from 18 results to 4. And so what's going on here when we go from rugged black jeans to rugged black jeans from a range of prices?
Right. So here, behind the scene, what we have done is like when we generated this particular catalog, we have identified the various product attributes and generate their models. So that we have generated the models for color, material, pattern, names, and price. That is a step one. The step two and more intelligent step is while you query from the query generating, this is a natural language query. From this natural language query, generating the query which understand by the search engine. So extract So the first, the lexicon analysis happens, then entity extraction happens, then the transformation. Like for example, here you written 30 to 150. So from this context, it identifies that we are talking about a price, and it will create a price range query. And also it will create a jeans as a product matching query. Then it's black, it will automatically identify that black belongs to the color, and it will identify rug belongs to the material. So as we were familiar with the e-commerce queries, they can understand that this thing normally otherwise user has to achieve via facet, which we have shown on the left hand side. In a typical side, you search for a jeans, then you go to the facet and try to go to the particular product you want. But with the NLP, user can type normally and they get result more intelligently, which is provided by big sites and Google as well. But most of the e-commerce sites don't have this capability, and people normally tend to search on Google for a particular site than on the site itself. And that with this capability, that difference can be avoided, and definitely it will, and we have seen the result, it will convert into the sales conversation and more lead generation for the business.
Okay, awesome. And so could you tell me a little bit, why are relevant results so important when it comes to e-commerce search?
Yeah, because the huge amount of number of products nowadays we have, and the number of information we have for each product, and due to the advancement of the technology and mobile technology, people are getting more and more impatient. And if they don't find the result in a first page or a first few products or more relevant result, they will be off from the site. So, the one way always we do in our assessment to identify how many times user get out from your website from the first page. And second thing is how many times user got zero results as the output because of not able to handle the complex query user has entered.
Okay. And so when is a time that you might prefer, or rather you would give a consultation to where boosting would actually be better than relevant results only?
Yeah, so that is comes to the particular, identify the particular selling product. Like if you know that this is the kind of a particular category of product being sold really well, this set of category products are sold really well, then we give the boosting to that particular category or that particular product or that kind of set of product. So they appear on the top, even though they are not be the highest relevant product according to the normal search. So that is where the particular product boosting and category boosting come into picture to sell their most sellable product and show them more often.
Okay. So now another example we had here is if we go ladies magenta crop top, say less than 300. So now, obviously, these types of categorizations aren't only given to just genders. Where are other examples where you'd see maybe even a B2B example, whether, let's say it was a construction company for suppliers versus just vendors? What are some other examples that you've seen of these overarching categorizations?
Right. So we have seen this kind of example, more. See, initially this kind of examples been adopted by the B2C companies because that's where they get a lot of natural languages queries. B2B companies are still evolving, and most of the time B2B company end users are typing only keywords because they have realized from the site that site don't understand the context or the particular English language sentences. So that is where the manufacturing companies are now highly adopting to this kind of NLP kind of construct where they can, based on the product attributes, like for example, temperature. So certain products works with certain temperature to temperature. So that is range queries. And then there is a directly mapping queries. So we can see that more and more B2B industries are now going towards the NLP set of queries, and they want that into their e-commerce website.
Okay, and then just one more question, and then I'll give it away to the audience. How would, just briefly, because we touched on the Amazon recommendations engine, How does NLP search tie into recommendations?
Yeah. So NLP is the first steps toward the recommendation engine. It's rather than recommended, it's try to find the best result and show it to you. Recommendation engine is a parallel technology, a parallel group of information and intelligence you need to build up according to the context of your business case, and that involves a lot of other parameter as well, like what you want to highlight, which product you want to recommend, and it comes with the personalization aspect where you create a profile for a user. And how you create a profile from the user, like over the time, what kind of things they search, how they browse their website, what kind of keywords they put, and also other metadata, if any, you have about the user. Like you can identify the location from where they are searching, you can identify from the various season going on. According to that, you can recommend certain product. According to the specific festival season going on, according to that, you can recommend a particular product or set of product. So recommendation engines internally contains the NLP, but itself is a parallel technology set on top of the standard search engines.
All right, awesome. Thank you so much for sharing that. So that's just about it from us. If you do have any other questions, please reach out to us at royalcyber.com. You can email me at david.aleman@royalcyber.com. We look forward to hearing from all of you, and thank you so much for being here with us today. And thank you, Mahipal, for sharing all this information with us.
Thank you, David. Thank you, everyone.